Now, in this lecture, we'll find out the radius of the circle. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. We know that the length of this line segment is equal to 140 units, and the length of this line segment is equal to 70 units, and our mission is to find out the radius of this circle. So, first of all, we will define the relevant points with names, letters. The touching point of the semicircle, with the biggest semicircle, we define this A. The center of this semicircle will be defined as B. The center of the biggest semicircle will be defined as O. The touching point between those two semicircles will be defined as D. The center of the smallest semicircle will be defined as E, and the touching point of the smallest semicircle with the biggest semicircle will be defined as F. Okay, we'll define the touching point of the biggest semicircle with the smallest semicircle as C. We'll define the center of this semicircle as F. And we'll define the touching point of this circle with the smallest semicircle as G. We'll define the touching point of this semicircle with this circle as H, and finally we will define the touching point of this circle with the biggest semicircle as I. Okay. It is given us the question that line segment AC, this line segment AC is equal to 140 plus 70 units. So AC, line segment AC equals to 140 plus 70 units. 140 plus 70 is 210 units. So AC equals to 210. Line segment AC equals to 210 units. So we will define the radius of the biggest semicircle as capital R, and the radius of this circle is small r. So I write it down. Capital R is the radius of the biggest semicircle, and small r is the radius of the circle, that is the radius that we are looking for. So we know that AC equals to 210 units in its length. What is actually line segment AC? It is very easy to see that line segment AC is the diameter of the biggest semicircle. Okay, again, line segment AC, it is the diameter of this biggest semicircle. And we know that the diameter of any circle or semicircle is twice as long as the radius. So that is to say, the diameter AC will be equal to 2 times the radius of this biggest semicircle, and we define the radius of this biggest semicircle as capital R. So AC equals to 2 times capital R. AC equals to 2 times capital R. It is the diameter of the biggest semicircle, and it is equal to 2 times capital R. That is, capital R is the radius of the biggest semicircle. So from this equation, 2R equals to diameter equals to AC equals to 210. We we derive that 2 times capital R equals to 210 units. Here we divide this equation by 2, and we get that capital R, that is to say the radius of the biggest semicircle, equals to 210 over 2, that is 105 units. So here capital R equals to 105 units. So we can write down in the drawing that the radius of the biggest semicircle equals to 105 units. OC is the radius of the biggest semicircle. Why? Because it starts from the center of the biggest semicircle, and that's at point C, that is the point of the biggest semicircle itself. Therefore, OC is the radius of the biggest semicircle, that is equal to 105 units. Likewise, AO or OA, it is also the radius of the biggest semicircle. Why? Because it starts from point O, that is the center of the biggest semicircle, and ends at point A, that is the point of the biggest semicircle itself. Therefore, OA, it is also the radius of the biggest semicircle, that is equal to 105 units. Okay, it is given us the question that this line segment AD, it is equal to 140 units. But what is the definition of line segment AD? AD is the diameter of this semicircle. Again, AD is the diameter of this semicircle, and we know that the diameter of this semicircle equals to 140 units. Therefore, the radius must be equal to half of it. That is to say, the radius AB of this semicircle equals to 140 over 2, that is 70 units. And the radius BD of this semicircle must be also equal to 70 units. Okay, BD is the radius of this semicircle. Why? Because it starts from point B, that is the center of the semicircle, and ends at point D, that is the point of the semicircle itself. This is exactly the definition of a radius. So BD is the radius of this semicircle, that is equal to 70 units. Likewise, it is given us the question that line segment DC, this line segment equals to 70 units. What is DC? DC is the diameter of the smallest semicircle. So we know that the diameter of this smallest circle equals to 70 units. Therefore, the radius must be equal to half of it. That is to say, the radius DE equals to 70 over 2, that is 35 units. And the radius EC of this smallest semicircle equals to also 35 units. Okay. In the next step, we will find out the length of this line segment BO. The length of line segment BO from the drawing, it is very easy to see that the length of this line segment BO, it is equal to OA minus BA. Again, OA minus BA equals to BO. BO equals to OA minus BA. Repeat again. BO equals to OA minus BA. So the length of line segment BO is equal to OA is the radius of the biggest semicircle, that is equal to 105 units. So we substitute OA by 105 minus BA. We just write down found out that BA equals to 17 units. This is the radius of this semicircle. So in conclusion, we found out that the length of line segment BO is equal to 105 minus 70, that is 35 units. So BO equals to 35 units in its length. So we can write down in the drawing itself that BO equals to 35 units in its length. Here, line segment BO equals to 35 units in its length. In the next step, we'll find out the length of this line segment OD. From the drawing, it is very easy to see that the length of this line segment OD equals to OC minus DC. Again, OC minus DC equals to OD. OC minus DC. Okay, OD equals to OC minus DC. So OD equals to OC. OC is the radius of the biggest semicircle, that is equal to 105 units. So we'll substitute OC by 105. Minus DC. DC equals to 35 plus 35, this is 70. So we substitute DC by 70. In conclusion, we found out that the length of line segment OD it is 105 minus 70, this is 35 units. So OD equals to 35 units in its length. So we can write down in the drawing itself that OD equals to 35 units in its length. This line segment equals to 35 units. In the next step, I will present to you two new rules and we will implement the two new rules in our drawing. We have rule number 10, and according to rule number 10, if two circles are touching each other internally, here in this drawing, we have the small circle is located inside the big circle. Therefore, at point N, the small circle touches the big circle, and therefore it is defined as internal lunge. That is to say, those two circles are touching each other internally. Why internally? Because the small circle is located inside the big circle. So those two circles are touching each other internally at point N. Okay? So whenever you have two circles that are touching each other internally, then the straight line that connects their centers together, point O is the center of the big circle. Point M is the center of the small circle. So OM is the straight line that connects their centers together. This straight line OM passes for point N. Okay, so the straight line that connects their centers together must pass for point N. That is to say, OMN is one straight line. OMN is one straight line. So whenever you have two circles that have an internal notch between them, that is to say they are touching each other internally, then the straight line that connects their centers together must pass for their touching point. In this case, the straight line that connects their centers together is OM, and OM must pass for their touching point, that is to say from point N. That is to say OMN is one straight line. And what is the length of OM, or what is the distance between their centers? It is OM, and OM equals to NO minus NM. Again, NO minus NM equals to MO. NO equals to capital R, NM equals to small r, and therefore MO equals to capital R minus small r. So the distance between their centers is the difference between their radii. That is to say, MO equals to capital R minus small r. Okay? So this is rule number 10, and then we have also rule number 11. According to rule number 11, if two circles are touching each other externally, here in this drawing, we have none of those two circles are inside the other circle, and therefore it is defined as that the two circles are touching each other at point N externally, because none of those two circles are inside of the other circle, and therefore those two circles are touching each other internally at point N. So according to rule number 11, the straight line that connects their centers together is OM. Why? Because O is the center of point of the big circle, and M is the center of the small circle, and therefore OM is the straight line that connects their centers together. So this straight line OM, according to rule number 11, must pass through point N, that is their touching point. That is to say, O and M is one straight line. O and M is one straight line, and because of the fact that O and M is one straight line, the distance between their centers OM must be equal to ON plus NM. ON is capital R, NM is small r, and therefore OM equals to capital R plus small r. So the distance between their centers, equals to capital R plus small r. That is the addition of the two radii with each other. Okay? So whenever you have an external notch between two circles, that is to say the two circles are touching each other externally at point N, then the distance between the centers of the two circles, that is to say OM, will be equal to capital R plus R. And whenever you have an external notch between two circles, then the straight line that connects their centers together, that is to say OM, must pass for their touching point. In this case, it's point N. So because of the fact that OM must pass for point N, it means that line segment ONM is one straight line. Okay? So actually we can implement rule number 11 in our drawing. Why? Because in our drawing we will actually connect the center of this semicircle with that is located at this point, point B, with the center of this circle that is located at this point, point F. So this circle and this semicircle have an external notch between them at point H. That is to say, they are touching each other externally at point H. And therefore, according to rule number 11, the straight line that connects their centers together, that is to say FB, the straight line FB must pass for their touching point. Their touching point is at point H, this point, therefore the straight line FB passes for point H. That is to say, FHB is one straight line. So FHB is one straight line, and the distance between their centers is the addition of the two radii with each other. That is to say, FB equals to FH plus HB. FH is the radius of this circle that is equal to R, small r, and BH is the radius of this semicircle that is equal to 70 units. So in total, BF, the distance between their centers BF, equals to 70 plus R units. So you can write down here that the length of line segment BF is 70 plus R units. BF equals to 70 plus R units. Likewise, we will connect the center of the smallest semicircle that is located here at point E with the center of this circle that is located at point F here. So this circle and this semicircle have an external notch between them at point G. That is to say, they are touching each other externally here at point G. And therefore, according to rule number 11, the straight line that connects their centers together, that is to say, the straight line FE, must pass for their touching point, that is to say, from point G. That is to say, FGE is one straight line. So FGE is one straight line. And what is the distance between their centers? That is to say, what is the length of FE? FE equals to the radius of this circle that is R, small r, plus GE, that is the radius of the smallest semicircle, that is equal to 35. That is to say, FE equals to in total to 35 plus R units. So you can write down that FE equals to 35 plus R units. And what is the length of line segment BE? From the domain, it is very easy to see that the length of line segment BE, it is BO plus OD plus DE. BO plus DO plus OB. Then actually, again, the length of line segment BE is ED plus DO plus OB. Again, EB equals to ED plus DO plus OB. So ED equals to EB equals to ED, that is 35, plus DO, that is also 35, plus OB, that is 35 also. So we found out that BE equals to 35 times 3, that is 105 units. So BE equals to 105 units in its length. In the next step, we'll join the center of the biggest semicircle that is located here at point O with the center of this circle that is located here at point F by a straight line. So the biggest semicircle is centered at point O, and it has an internal notch with this circle is point I. That is to say, the biggest semicircle touches the circle at point I. So they have an internal notch between them at point I. And whenever you have two circles with an internal notch between them, according to rule number 10, the straight line that connects their centers together, that is to say OF, must pass for their touching point, that is to say from point I. So OF must pass through point I. That is to say, OFI is one straight line. According to rule number 10, OFI is one straight line. Here OFI is one straight line. And what is the distance between their centers? The distance between their centers is FO. And what is the length of FO? It is equal to capital R minus small r. Okay, so FO equals to capital R, that is the radius of the biggest semicircle, minus small r, that is the radius of the circle. So FO equals to capital R. We have already found out that the radius of the biggest semicircle equals to 105 units. Minus R. R is the radius of the circle. So in conclusion, we found out that FO, the distance between the centers FO equals to capital R minus small r, that is 105 minus small r units. 105 minus small r units. So in the next step, I will present to you a new rule, and we will implement the new rule in triangle FBE. In the green triangle, triangle FBE. The new rule is true in any triangle, and for that reason we can implement it in this green triangle, triangle FBE. The new rule is called Stewart's theorem. So the triangle that I will draw could be any triangle. So this is triangle ABC. That could be any triangle. We know that the length of side AB is equal to A units, side AC equals to B units in its length, and finally side BC equals to C units in its length. In addition, we have here line segment AO that is equal to D units in its length. We also know that line segment BO equals to M units in its length, and the line segment OC equals to N units in its length. So, according to Stewart's theorem, the following equation is true. That A squared times N plus B squared times M equals to C. C is the length of side BC. C, and inside the brackets we have D squared plus M times N. Okay? So according to Stewart's theorem, this equation is true in any triangle. That A squared times N plus B squared times M equals to C, and inside the brackets we have D squared plus M times N. Okay? So actually can implement Stewart's theorem in our triangle, because this law or this theorem is true in any triangle, and especially in our triangle FBD. FBE. This is the green triangle is triangle FBE. So we implement Stewart's theorem in the green triangle FBE. I will copy triangle FBE in a new page and we'll implement on it Stewart's theorem. We have already found out all the sides of this green triangle FBE, and also we know that line segment F4 equals 205 minus our units. Side FB equals to 70 plus R units. Side F equals to 35 plus R units. And finally, BE, side BE equals to 105 units. In addition, we also know that line segment FO equals to 105 minus R units. So this is actually the green triangle FBE that I copied from the original drawing. What is the length of side BO? From the drawing it is very easy to see that the length of this side BO is equal to 35 units. So it is not according to the scale. BO equals to 35 units, and the length of this side OE is equal to 35 plus 35, that is 70. OE equals to 70 units. Actually, line segment OE should be twice as long as line segment BO. It is not according to my drawing, but we will consider OE is twice as long as BO. Okay. So we will implement Stewart's theorem in our triangle FBE. According to Stewart's theorem, BF squared times OE, BF squared times OE plus FE squared times BO equals to BE and inside the brackets we have FO squared. FO is 105 minus R, therefore FO squared is 105 minus R squared plus BO times OE. BO times OE. Again, so this equation is the implementation of Stewart's theorem in our triangle FBE. BF is 70 plus R, therefore BF square is 70 plus R square times OE. OE is 70, therefore, okay, so we substitute OE by 70 plus FE square. FE is 35 plus R, therefore FE square is 35 plus R square times BO. BO is 35, therefore we substitute BO by 35. And it is equal to BE. BE is 105 units, therefore we substitute BE by 105. And inside the brackets we have 105 minus R square plus BO is 35 times OE, that is 70. Okay. In the next step, we will define the number 35 as x, and we will substitute in this equation 35 for any multiplication of 35 by a natural number. We'll substitute it by x. And we'll get that we have here 70. 70 is 35 times 2, therefore it is 2x, because x equals to 35, plus R square times 70. 70 is 2 times 35, that is to say it is 2x, plus, we have inside the brackets 35, this is x, plus R square, times 35, it is x, so we substitute 35 by x. And it is equal, on the other side of the equation we have 105. 105 is 35 times 3, or 3 times 35. So we substitute 105 by 3 times x. And inside the brackets we have, again, 105 is 3x minus R square plus 35 is x. 70 is 2 times 35, that is to say it is 2x. So, in conclusion, we found out that this is our equation after we substituted 35 by x. So here we will divide this equation by x, and we will get that so here x will get cancelled, here also x will get cancelled, and here also x will get cancelled. So what is left from this equation after we cancelled, after we divided by x? In this side of the equation we have 2x minus R square times 2 plus x plus R square equals to 3. Inside the brackets we have 3x minus R square plus x times 2x is 2x square. Okay? So here we have 2 times, and we will open the brackets here. 2x minus r squared equals to 2x squared, 2x squared is 4x squared plus r squared minus 2 times 2xr is minus 4xr. We'll open the brackets here. X plus r squared equals to x squared plus r squared plus 2xr. In the other side of the equation we have 3, and inside the brackets we have 3x minus r squared according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. It will be equal to 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr. And we have here plus 2x squared, all under the brackets. Here we will open the brackets here, that is to say we will multiply each one of the expressions inside the brackets by 2. 2 times 4x squared is 8x squared, 2 times r squared is 2r squared, and 2 times minus 4xr is minus 8xr. And we have here plus x squared plus r squared plus 2xr. That is equal to, here we have inside the brackets 9x squared. We have 3 times 9x squared plus 2x squared is 11x squared. Plus r squared minus 6xr. Okay, so here we have 8x squared plus x squared is 9x squared. Here we have 2r squared plus r squared is 3r squared. And here we have minus 8xr plus 2xr. It is actually minus 6xr, but here I think I made a mistake. Here minus 8xr. And here we have x squared plus r squared plus 2xr. Okay, so it is on the other side of the equation we have 3 times 11x squared is 33x squared plus 3 times r squared is 3r squared, and 3 times minus 6xr is minus 18xr. So here we have it again. 70 plus r square times 70 plus 35 plus r square times 35 equals to 105 minus r square is 45 times, okay. Then we did here, right, here it is actually 2x plus r. 70 plus r square, it is 2x plus r square. So it is not minus but it's plus. It's 2x plus r square times 2x, x plus r square, 3x minus r square. Okay, so here it is not 2x minus r, but it is 2x plus r. Here also it is 2x plus r. So actually 2x plus r square is 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr is 4xr. And here 2 times 4xr is 8xr. So here we have 9x squared plus 3xr, 9x squared plus 3r squared, plus 10xr plus 2xr, 8xr plus 2xr is 10xr. 10xr equals to 35x squared plus 3r squared minus 18xr. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. What is left from this equation after we cancelled 3r squared? We will actually subtract 9x squared from this equation, and we'll get that 9x squared minus 9x squared is 0. So in this side of the equation we left only with 10xr. That is equal to 33x squared minus 9x squared is 24x squared. Minus 18xr. Here we will add 18xr to this equation, and we will get that 10xr plus 18xr is 28xr. That is equal to 24x squared. So if I order the 28xr equals to 24x squared. Here we will divide this equation by x, and we will get that 28xr over x is 28r. That is equal to 24x squared over x is 24x. In conclusion, found out that 28r equals to 24x. Here we'll substitute x by 35 because of the fact that according to our definition, x equals to 35. So 28r equals to 24 times x, x is 35. Here we'll divide this equation by 7. 28 over 7 is 4, so in total in this side of the equation we have 4r. That is equal to 24, and 35 over 7 is 5. So in conclusion, we found out that 4r equals to 24 times 5. Here we will divide this equation by 4. 4r over 4 is r. 24 over 4 is 6. So in total in this side of the equation we have 6 times 5. So r equals to 6 times 5, that is 30 units. So we found out that the radius of this circle R equals to 30 units. In the next step, I will summarize the lecture. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. It is given as the question that line segment AD equals to 140 units and line segment DC equals to 70 units in its length. And our mission is to find out the radius of this circle. Okay, so actually it is given as the question that line segment AC equals to 140 plus 70 units. So AC equals to 140 plus 70 units, that is 210 units. So AC equals to 210 units. Then we define the radius of the biggest semicircle as capital R, and the radius of this circle is small r. Small r is the radius that we are looking for. Okay, again, capital R is the radius of the biggest semicircle, small r is the radius that we are looking for, it is the radius of the circle. We know that AC is the diameter of this biggest semicircle, and the diameter of any circle or semicircle is twice as long as the radius. And because of the fact that the radius of the biggest semicircle equals to capital R, it means that the diameter must be equal to twice of it, that is to say to 2 times capital R. Okay, so here the diameter of the biggest semicircle equals to 2 times capital R. That is equal to AC, and we already found out that AC equals to 210 units. So from this long equation, we will derive that 2 times capital R equals to 210 units. We'll divide this equation by 2 and we get that R equals to 105 units. Here, AO, that is the radius of the biggest semicircle, equals to 105 units, and OC, this is also the radius of the biggest semicircle, equals to 105 units. Why OC is the radius of the biggest semicircle? Because of the fact that the center of the biggest semicircle is at point O, and point C is the point of the semicircle itself. This is exactly the definition of a radius. OC is the radius of the biggest semicircle that is equal to 105 units. For the same reason, exactly, OA also equals to 105 units. This is the radius of the biggest semicircle. Okay? So, it is given as the question that line segment AD equals to 140 units. But what is line segment AD? Line segment AD is the diameter of this semicircle, and therefore the radius must be equal to half of it, so the radius AB equals to 70 units, and the radius BD of this semicircle equals to 70 units. Likewise, it is given as the question that line segment DC equals to 70 units in its length. But what is line segment DC? DC is the diameter of this semicircle that is equal to 70 units. Therefore, the radius DE must be equal to half of it, that is to say to 70 over 2, that is 35 units. And the radius AC must be also equal to 35 units. In the next step, we found out the length of line segment BO. From the drawing, it is very easy to see that BO equals to OA minus BA. OA minus BA equals to BO. Again, BO equals to OA minus BA. OA is 105 units. This is the biggest and the radius of the biggest circle. BA is the radius of this semicircle that is equal to 70 units. So in conclusion, we can write down that BO is 105/170, that is 35 units. So the length of this line segment BO is 35 units. What is the length of line segment OD? From the drawing it is very easy to see that OD equals to OC minus DC. Again, OC minus DC equals to OD. Repeat again that OD equals to OC minus DC. So OD equals to OC minus DC. OC equals to 105 units, this is the radius of the biggest semicircle. DC equals to 70 units. This is the diameter of this smallest semicircle. Therefore, in conclusion, we found out that OD equals to 105/170, this is 35 units. So OD equals to 35 units in its length. This line segment OD equals to 35 units in its length. In the next step, actually presented to you two new rules, and we implemented the two new rules in our drawing. We have rule number 10. According to rule number 10, if two circles are touching each other internally, here the smallest circle is located inside the big circle, and therefore it is defined that the small circle touches the big circle at point N. Therefore, we will define it that here we have an internal arch. That is to say, the circles are touching each other internally at point N. Why? Because the small circle is located inside the big circle. So the two circles are touching each other internally at point N. Then according to rule number 10, the straight line that connects their centers together, point O is the center of the big circle, point M is the center of the small circle. Therefore, OM is the straight line that connects their centers together. So this straight line OM must pass for their touching point, that is actually point N. So OMN is one straight line. According to rule number 10, OMN is one straight line. Okay, so whenever you have an internal arch between two circles, then the straight line that connects their centers together must pass for their touching point. In this case, the straight line OM must pass for point N, that is to say OMN is one straight line. And what is the distance between their centers? That is to say, what is the length of line segment OM? D, that is the length of line segment OM, equals to ON minus MN. OM is capital R, MN is small r, that is to say OM equals to capital R minus small r. So the distance between the centers of the two circles is the difference between their radii, capital R minus small r. This is rule number 10, and we also have rule number 11. According to rule number 11, if two circles are touching each other externally, here none of those two circles are inside of the other circle. Therefore, we will define here that those two circles are touching each other externally at point N. Point N is the point of tendency of their touching point. The center of the big circle is at this point, point O. The center of the small circle is at this point, point M. And the straight line that connects their centers together is OM. So this straight line OM must pass for their touching point, that is to say it must pass for point N, that is their touching point. Or in other words, O and M is one straight line. O and M is one straight line. According to number 11, and what is the distance between their centers? The distance between their centers is OM. And what is the length of OM? D is the length of OM, and D equals to ON plus NM. ON is capital R, NM is small r, therefore OM is capital R plus small r. That is to say, the distance between their centers is the addition of the two radii with each other. So we can implement the two new rules in our drawing. Why? Because in our drawing we join the center of this semicircle with the center of this circle. The center of this semicircle is located at point B, and the center of this circle is located here at point F. So here, this circle have an external edge with this circle at point H. That is to say, they are touching each other externally at point H. And according to rule number 11, the straight line that connects their centers together, that is to say, the straight line FB must pass for point H, that is their touching point. That is to say, FHB is one straight line. FHB is one straight line. And what is the distance between their centers? The distance between their centers is FB. And what is the length of FB? The length of FB is the addition of the two radii with each other. The radius of this circle is small r. The radius of this circle is equals to 70 units, and therefore r plus 70 units equals to FB. I repeat again, FB or BF equals to 70 plus r units. Likewise, we will join the center of the smallest semicircle that is located here at point E with the center of this circle that is located here at point F. So the semicircle have an external edge between this circle at point G. That is to say, they are touching each other externally at point G. And therefore, the straight line that connects their centers together is FE. So this straight line FE must pass for their touching point, that is to say, from point G. Or in other words, FGE is one straight line. FGE is one straight line. And the distance between their centers is FE. FE, according to rule number 11, equals to the addition of the two radii with each other. So FE equals to small r, that is the radius of this circle, plus 35, that is the radius of the smallest semicircle. So in conclusion, we found out that FE equals to r plus 35, or 35 plus r. FE equals to 35 plus r. And what is the length of this line segment BE? From the domain, it is very easy to see that the length of line segment BE equals to BO plus OD plus DE. Again, BE equals to BO plus OD plus DE. BO equals to 45. OD equals to 40. BO equals to 35 units. OD equals to 35 units. And DE also equals to 35 units. Therefore, BE equals to 35 times 3, that is 105 units. Repeat again that BE equals to 105 units. Okay, in the next step, we actually connected the center of the biggest semicircle that is located at point O with the center of this circle that is located here at point F. We connected those two centers together by a straight line, and according to rule number 1, the straight line that connects their centers together, that is to say, the straight line OF, must pass through their touching point, and their touching point is this point I. That is to say, OFI is one straight line. OFI is one straight line. And what is the distance between their centers? The distance between their centers is FO, because O is the center of the biggest semicircle, F is the center of this circle, and therefore FO is the distance between their centers. And according to rule number 10, the distance between their centers equals to the difference between their radii. That is to say, it is capital R minus small r. I repeat again, that the distance between their centers FO equals to capital R minus small r. But we have already found out that the radius of the biggest semicircle equals to 105 units in itself, and the radius of the small circle equals to small r according to our definition. Therefore, capital R minus small r, it is 105 minus small r units. So here FO equals to 105 minus small r units. In the next step, I presented to you a new rule, and we implemented the new rule in our green triangle, triangle FBE. The new rule is true in any triangle. So here, triangle ABC could be any triangle. The length of side AB is A units. Side AC equals to B units in its length, and side BC equals to C units in its length. We have also line segment AO equals to D units in its length. Line segment BO equals to M units in its length, and line segment OC equals to N units in its length. Then according to Stewart's theorem, the following equation is true. A squared times N plus B squared times M equals to C times D squared plus MN. Again, A squared times N plus B squared times M equals to C, that is the length of side BC, times D squared plus M times N. Okay? Again, A squared times N plus B squared times M equals to C. And in the brackets we have D squared plus M times N. So we can implement the new rule in our triangle, the green triangle, triangle FBE. So this is actually the green triangle, triangle FBE that I copied from the original drawing. We've already found out all the sides of this triangle. I will not repeat on it. We also found out that of FO equals to 105 minus R. What is the length of line segment BO? It is very easy to see that BO equals to 35 units in its length. BO equals to 35 units. And what is the length of line segment OE? From drawing it is very easy to see that OE equals to OD plus DE. OD equals to 35 units and DE also equals to 35 units. Therefore, OE equals to 35 plus 35, that is 70 units. Here, OE equals to 70 units in its length. It is not according to what is supposed to be, because OE is supposed to be twice as long as BO, but we consider the OE is twice as long as BO. Okay, so here we implemented in this triangle, triangle FBO, Stewart's theorem. According to Stewart's theorem, in this triangle, triangle BFO or BFE, BF squared times OE plus FE squared times BO equals to BE, and in the brackets we have FO squared plus BO times OE. Repeat again, BF squared times OE plus FE squared plus BO equals to BE, and in the brackets we have 105 minus R squared plus BO times OE. BF equals to 70 plus R, therefore BF squared is 70 plus R squared times OE. OE equals to 70 units, so we substitute OE by 70 plus FE squared. FE equals to 35 plus R, therefore FE squared equals to 35 plus R squared times BO. BO equals to 35, so we substitute BO by 35. And it is equal, on the other side of the equation we have BE, that is 105, so we substitute BE by 105. Inside the brackets we have actually here, it is FO. Here FO, so I actually wrote down the value of O immediately, but here it's supposed to be FO, and we know that FO equals to 105 minus R, so we should substitute FO by 105 minus R, and FO square equals to 105 minus R square plus BO, it is 35, so we substitute BO by 35 times OE. OE is 70, so we substitute OE by 70. So this equation is true according to Stewart's theorem. In the next step we defined 35 as x, and we substituted 35 in this equation, or the multiplication of 35 by a natural number with x. And we found out that 70 is 2 times 35, therefore 70 is 2x plus r squared times 70 is 2x plus 35 plus r is x plus r squared times 35 is x. So it is x plus r squared times x, that is equal to 105 is 35, 3 times 35, that is 3x. Inside the brackets we have 105, that is 3x, so it is 3x minus r squared plus 35 is x, 70 is 2 times 35, that is 2x. So here we have x times 2x. So we got this expression. After we substituted 35, or the multiplication of 35 by a natural number, by x. Okay. In the next step we divided this equation by x. So here x will get cancelled, x will get cancelled, and here also x will get cancelled. What is left from this equation after we cancelled x? What is left is, here we have 2x plus r squared times 2 plus x plus r squared equals to 3. Inside the brackets we have 3x minus r squared plus 2x squared. Here we open the brackets. So we have here 2 times 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared plus 2 times 2xr is 4xr. Okay, all multiplied by 2. We have here x plus r squared is x squared plus r squared plus 2xr, and it is equal to 3. Inside the brackets we have here 3x minus r squared, 3x minus r squared according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. So 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr, and plus 2x squared. Then we open the brackets here, that is to say we multiplied all the expression inside the brackets by 2. 2 times 4x squared is 8x squared, 2 times r squared is 2r squared, and 2 times 4xr is 8xr. And we have also here x squared plus r squared plus 2xr. That is equal to, here inside the brackets we have 2x squared plus 9x squared is 11x squared plus r squared minus 6r. So here we have 9x squared, 8x squared plus x squared is 9x squared, and we have also plus r squared, and again 8x squared plus x squared is 9x squared, and we have here 8xr plus 2xr is 10xr, and 2r squared plus r squared is 3r squared. So in total in this side of the equation we have 9x squared plus 3r squared plus 10xr. Here we open the brackets, and we got that 3 times 11x squared is 33x squared, and 3 times r squared is 3r squared. 3 times minus 6xr is minus 18xr. Okay, so in this side of the equation in total we have 33x squared plus 4r squared minus 18xr. 33x squared minus 33x squared plus 3r squared minus 18xr. Here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we subtracted 9x squared from this equation. 9x squared minus 9x squared is 0, so in this side of the equation, we left only with 10xr. On the other side of the equation, 33x squared minus 9x squared is 24x squared minus 18xr. So in conclusion, we found out that 10xr equals to 24x squared minus 18xr. Here we added 18xr to this equation and we found out that 10xr plus 18xr is 28xr, and this is equal to 24x squared. 18xr minus 18xr is 0. So in conclusion, we found out that the 28xr equals to 24x squared. Here we divided this equation by x, and we found out that 28xr over x is 28r, and it is equal to 24x squared over x is 24x. So in conclusion, we found out that 28r equals to 24x. Here we substitute x by 35 because of the fact that according to our definition, x equals to 35. So 28r equals to 24x, and 28r equals to 24 times x is 35. So in conclusion, we found out that 28r equals to 24 times 35. Here we divided this equation by 7. 28 over 7 is 4. In total, in this side of the equation, we have 4r, and it is equal to 24 times 35 over 7 is 5. So in total, in this side of the equation, we have 24 times 5. In conclusion, we found out that 4r equals to 24 times 5. Here we divided this equation by 4. 4r over 4 is r, and 24 over 4 is 6. So in this side of the equation, in total, we have 6 times 5. So we found out that in conclusion that r equals to 6 times 5. 6 times 5 is 30. So in conclusion, we found out that r equals to 30 units. R, the radius of this circle, the radius that we are looking for, equals to 30 units. Okay? Thank you very much.